Hello friends, we are back here with special type of loops wherein we have more than one manipulated variable and we have more than one output. So we call them as MIMO, multiple input, multiple output. The question is that if I have two CISOs, CISO is single input, single output. If I have two CISOs, will that make MIMO? In that case also you will have two inputs. In that case also you will have two outputs. Let us explore what is the answer to this question. You see over here in this figure we have one manipulated variable and this is giving me one output through this block, and this block is named as H11. It's always you have the output first and the input. Even in case of efficiency, you say efficiency is equal to output upon input. So here output is 1, input is 1, so therefore this block is named as H11. Similarly, over here you have manipulated variable M2, and this manipulated variable M2 is giving me the output Y2, and therefore the block which is determining the relationship between y2 and m2 is named as h22, right? Output is 2, then followed by input which is again 2. But here we see that the m1 over here is not only affecting y1, but it also is affecting y2, and this relation between y2 and m1 is determined by the block h21, because the output is 2 y2 and input is 1 m1, and as I told you earlier, it's always first output then input. Therefore this is designated as h21. And similarly, this manipulated variable m2 is also affecting y1, and therefore the relationship between y1 and m2 is given by h12. It's output upon input. Output is y1, input is m2, and therefore the block defining this relationship is named as h12. So guys, over here we find that the overall effect, if we see how is y1 affected, y1 is affected by m1 through this block, and y1 is also affected by m2 through this block. Therefore you say that y1 is equal to h11 into m1 plus h12, this is h12, into m2, this is m2. And similarly for y2 also we get a similar equation. The only difference is that 1 is replaced by 2 and 2 is replaced by 1. So here we see that if we have two CISOs, means in that case this m1 will be there, this y1 will be there, this block will be here, m2 will be here, y2 will be here, this block will be here. But these two blocks will not be there. These two are the interacting blocks. These are called interacting blocks because they are giving me the interaction of this input output loop with this one, and this block is making the lower loop to interact with the upper process, and therefore we have an overall four kinds of interacting blocks. This actually makes MIMO. In case we have two CISOs, in that case this block will not be there, this block will not be there. In that case two MIMOs, they will not make, two CISOs will not make one MIMO. So that is the answer two CISOs do not make a MIMO, because we have to have all these four blocks and just two blocks will not do. So guys, we have this entire process wherein you have two manipulated variables and you have two outputs, and we apply a feedback control in the upper loop, we apply a feedback control in the lower loop. But as such, if we give any change in the set point over here, it not only affects y1, but it also affects y2. And similarly, any change in set point over here is not only going to affect y2, but is also going to change y1. And this kind of interaction is very dangerous, in the sense that it complicates the things to such an extent that the equations become very heavy and the control becomes very difficult, as we are going to see in the forthcoming slides. What we see over here is that in this case, you see over here, the manipulated variable m1 is going to be the error that is generated on account of change in set point over here, multiplied by gc1. And similarly, the manipulated variable m2 is going to be the error which is generated on account of change in set point over here, or it can be on account of some disturbance that will be generating the error, multiplied by gc2, and that is going to give me m2. So guys, this is the overall loop. In the forthcoming slides, we shall not be showing these blocks h11, h21, h12, h22. We will simply be showing this dotted rectangle or square, whatsoever you may call it, in such a manner that all this inner thing will be condensed, and you have to imagine that there is h11, h21, h12 and h22 over here. All these addition blocks are to be imagined. This is to conserve space so that we can move forward in a more systematic manner. So guys, we see here that in case we have only first loop, that is the first loop over here, is getting the feedback, there is no change, in the manipulated variable over here, and therefore this y2 is supposed to be constant in absence of any input from m2. But what happens is that whenever there is any disturbance over here and the feedback is not matching with the set point, there is some error over here, the controller tries to correct this error by giving m1 with all its good intentions to bring y1 back to the set point. But in doing so, this controller is inadvertently passing on its effect to y2. It means that this y2 is unnecessarily, unintentionally getting affected by whatsoever was the change which was brought about in y1. That was to be corrected by putting in some action by gc1 over here, but that is disturbing y2 over here, in spite of the fact that this m2 is constant, there is no change in the manipulated variable over here. So this is represented mathematically by these set of equations as y1. It is quite understandable. Y1 is equal to h11 into gc1 divided by 1 plus h11 gc1. So this as such is what is expected in case of a regular control loop also, wherein this denominator gives the stability of the equation. But in addition to this, in spite of the fact that we have no manipulated variable getting changed in the lower loop, this y2, the output of the lower loop, is also getting affected by any change in the upper loop. That is, any change in the set point of the upper loop is not only going to affect the output of the upper loop, but the change in set point of upper loop is also going to affect the output of the lower loop. This is because of the interaction. See, this was the effect of upper loop on upper loop itself, and this is the effect of input in the upper loop to the output of the lower loop because of the interaction. What happens when both the effects, like we have the upper loop which is also having some feedback and the lower loop is also formed on account of feedback, in that case I told you things will be becoming too complicated in the sense that let us change some set point in y1. So this change in set point in y1 is going to introduce an error over here. This is going to act upon the controller. The controller is going to give some manipulated variable which is going to change y1 directly. That is okay, that is cool, that is required. But what happens is that as this direct effect is felt by y1, along with it this m1 is also changing y2. This y2 gets disturbed, and to bring this y2 back to its original point, what will happen is that this y2 will generate, the change in y2 is going to generate some error over here, and the controller gc2 is going to bring y2 back to the normal point. And in order to bring it back to the normal point, it's going to change the manipulated input to the process M2, and this M2 is going to again affect Y1. So guys, this Y1 is getting affected by the change in set point over here. One route is this route, which is the direct effect, and the other route is indirect effect, that this upper loop is disturbing the lower loop. The lower loop, after getting disturbed by the upper loop, tends to bring the lower loop back into the original point, and this M2 is changing, which is again affecting the upper loop. So this upper loop is getting affected directly through this route, and indirectly, as you can see over here, through the dotted lines through this loop. And this indirect effect is going to make the control of upper loop as well as lower loop quite complicated, as you can see from here. These equations, as you see over here in these equations, you have y1. This y1 is this output over here. It is getting affected by the change in set point of y1 over here, which is quite understandable, but it also will be affected by the change in set point of y2 because of the interaction. And similarly, the output of the lower loop y2 will not only be affected by the change in set point of y1, but will also be affected by the change in set point of y2. Like both of these will be getting affected by both of the outputs, will be getting affected by both of these set points over here, and that makes the things too much complicated. So these are given by, again, these equations which I'll be showing in the next slide. P11, as the notation says, you first have output and then have input. This is again first have output, output is 1, and input is changed in set point 2, so this is P12. In this case, as you can see, the output is y2 and the input is y1, change in set point. So this block is designated as P21, and this will be taken as P22. And see, we are going to see what is the value of P11, what is the value of P12, what is the value of P21 and what is the value of P22 in the next slide. But just keep in mind that all these blocks, whether it's P11 or P12, they will be all be playing around six elements. First element is what? GC1, which you can see over here. Second element is what? GC2, which you can see over here. Third element is what? This H11, which you cannot see, but you remember this was H11. Similarly, this is H22. Similarly, this is H21. It's output upon input. And similarly, you have H12. Output is Y1, input is M2. So all these six blocks, first, second, third, fourth, fifth, and sixth, all these six blocks are going to be there some manner in P11, P12, P21, and P22, as we're going to see in the next slide. Guys, this is the next slide. I told you P11, it has H11, GC1, GC2, H22, H12, H21, and QS. Something in denominator we will see in a moment. Similarly, you have P12, P21, and P22. Again, as I told you, if you want to come from this equation to this equation, the simple trick is that replace all ones by 2. This is 1, this is 1, replace it by 2, replace it by 2. This H11 becomes H22. This GC1 becomes GC2. This GC1, GC2 remain GC1, GC2 even after you replace them, and so on. You see that everything over here is simply by replacing 1 by 2 and 2 by 1, you will come to this equation. Similarly, replacing 1 by 2, like you have P12, it becomes P21, this 1 2 becomes this 2 1, this GC2 becomes GC1, replacing 1 by 2 and 2 by 1. So in case you are able to remember this equation and this equation, from there you can get this equation and this equation. Now the question is, what is QS? As we have seen, as we derive this equation, we find that this QS is the denominator in all these things is given by not only H11 GC1, which is quite understandable, not only by H22 and GC2, which is quite understandable, but also by this term which is containing the remaining four terms. I told you that entire game is of six terms, right? So you have all these terms coming over here, and this QS is going to determine the stability of this entire system, because this is in denominator, and you put denominator equal to 0, you will get the poles on the left means system is stable, poles on the right means system is unstable. So that simple equation, as we have been studying right from the beginning, we will be getting this from this QS. So we have to design the system in such a manner that this QS, it has all the roots in the negative plane of the S graph as such. So we have stable roots, poles on the left, system is stable. That makes the things too complicated. So how do we deal with this? How do we design the things? How do we ensure the stability? How do we control the two loops which are in MIMO? We shall be going through all these things in the subsequent video sessions. And till then, in case you have any queries, let me know through any of the means. In case you want to share something with me, I hope you have enjoyed this session as well. I thank you for being with me. I wish you a very safe stay.